Hi everyone, this is DNM Goda lecturer, APS Polytechnic, Somnalli, Bangalore. I welcome all of you to this class transmission, distribution and utilization session 13. In this session, we shall expose to a new technology in transmission, the FACTS, flexible AC transmission system. Here we have different terms, objectives of FACTS, different types of controllers and their functions. Finally, we will be reviewing the entire session with the help of multiple choice questions. Before exactly going to this fact system, a new technology of transmission, we shall recall the generation, the places of generation, transmission, etc. The modern society demands a huge electrical power. So in order to produce electrical power in large quantity, huge resources are necessary. The resources may be water power, fuels like coal and nuclear, etc. In order to harness the water power, we require the reservoirs. These reservoirs are built far from the load centers in remote areas. There, the power stored in water in the form of potential energy and kinetic energy will be converted into mechanical, in turn it will be converted into electrical energy. In case of thermal power stations, we use the main fuel as the coal. This coal when burnt produces heat which will be converted into a mechanical energy using steam turbines, then it will be converted into electrical energy. While producing heat, a lot of pollution will be produced. In case of nuclear power stations, the fuel used is the nuclear fuels, uranium like that, and safety of human beings is very important. For all these reasons, we cannot build the generating stations using water power or thermal power or this nuclear power near to the load centers. Therefore, they should be built far away from the highly populated areas. Therefore, once we have generated this electrical energy, it is to be transmitted. The conveyance of electrical energy from generating stations to the load centers may be called as electric power supply. In this electric power supply, the transmission system plays a very important role. Then what is meant by transmission system? A huge network of conductors meant for transmitting electrical energy may be called as the transmission system. The energy is being produced in the form of AC as high voltage can be generated. It may be around 6.6 kV or 11 kV. But we cannot transmit the power at this level of voltage. Therefore, it has to be raised to a very large value like 220 kV or 400 kV. Once we have raised this to a larger value, then it will be transmitted over a long transmission lines to the load centers. There once again it will be converted to different levels and distributed. This transmission system may be called as high voltage AC transmission system. The main reason behind the high voltage transmission system is it has got a large number of advantages. First and the foremost is the high voltage reduces the total amount of the copper material or conducting material used in transmission lines, therefore it becomes economical. The line currents are reduced, hence the losses will be reduced, and hence the efficiency of transmission increases. Moreover, it decreases the percentage line drops. Therefore, we can supply the power at good quality. In spite of all these advantages, we have some of the disadvantages of this fact system also. Several parameters impose limitations on usage of this high voltage AC transmission. The first and the foremost thing is reactive power loss. All transmission lines have the line constants, line capacitance, line inductance, and the resistance. This line constants vary in nature. This variable impedance has to be compensated. So the reactive power loss may be the sum of the reactive power generated due to the line capacitance or consumed due to inductive reactance. During light load conditions, the inductive reactance absorption will be less when compared to the reactance power generated. On contrary, at peak load hours, the inductive reactance power absorbed would be more when compared to the capacitive reactance produced. Therefore, continuously there will be varying in nature. This impedance is to be compensated. This may be called as the reactive compensation. The second is the stability problem. We are going to send the generated power to the receiving end. This transmission of power mainly depends upon two levels of voltages, the sending end voltage and receiving end voltage, and their angles. During light load conditions, the angles may be in quadrature, that is about 90°. At transient, it may reduce to a minimum value, almost becoming zero. And such conditions, beyond these conditions, the systems become unstable because AC system is working in synchronism. If it becomes unstable, it would be very difficult for transmission of electrical power. Then the current carrying capacity. Due to the line capacitance, and since the AC transmission is of long length, then the capacitance effect is very, very large. Even during no load conditions, there will be a current flow in the receiving end due to the charging. This may rise up to thermal current limit. So this is very much similar to the vehicles used for transportation purpose may be having a very large dead weight. These vehicles are meant for transportation, but due to its dead weight, it will not be possible to transport the goods and human beings. This condition is very similar to this, the charging current of the transmission line. Therefore, this parameter is to be compensated. Operation and control. So, due to all these constraints, the power flow in a transmission line cannot be controlled properly unless and until we are going to use extra devices. The devices may be power electronics based on other static components which can be included in the AC transmission system, which will lead to flexible AC transmission system. Then how can we define this? Facts, flexible AC transmission system which incorporates or utilizes The parallel based and the static controllers to enhance the controllability and static controllers to enhance the power transfer capability. So in order to achieve, we have two objectives. The first one is to increase the power transfer capability of transmission system. In this, the power flow can be increased by injecting current into the system so that the total real power transfer would be maximum. The second one is to keep the power flow over a designated route. Since we have large network of conductors, we have to force this the power transfer in the intended route so that we can increase the efficiency of the system. For this purpose, in order to implement the fact system, we are going to introduce the power electronics based systems and other static equipments. These are the equipments which will provide the reactive compensation. These are actually represented by a symbol as shown in the figure below. These FACTS controllers are nothing but the devices which can be used for switching different impedance parameters like capacitive reactance, inductive reactance, a power frequency related components, or the phase angle introduction like this. So in case of this power controls, we have different types. Depending upon the compensation, we will be having different types of FACTS controllers. The first and the foremost one, a series controller. The second one is shunt controllers, combined series controllers, combined series shunt controllers, in which we have two different types, the coordinated series shunt controller or a unified series shunt controller. Let us take one by one. The first one is the series controller. A series controller is a device, a power electronics based device, which may be a variable impedance like the capacitors or reactors, which are introduced in the line. So when variable impedance is connected in series with the line, and the current that flows through this will have the voltage drop, may be called as the reactive drop. So this is same as, so injecting the reactive voltage in series with the line so that actually the compensation can be achieved in order to transfer maximum amount of power. The second one is the shunt controllers. This is also a variable impedance, may be capacitive in nature, inductive in nature, and these are connected to a system voltage which will produce the current. This is same as inducing the current into the line in order to increase the power transfer capability. Combined series controllers. Here in different line we have independent series controllers, which are nothing but the variable impedances connected to two different lines, and they can be unified so that a power DC link can be introduced. The series controllers induce the reactance voltage in series with the line in order to increase the power, and at the same time, so there may be transfer of real power from one line to another. This is possible in case of combined series controllers. The last one is the combined series shunt controller. This may be a combination of separate series controllers and shunt controllers. Series controllers are responsible for introducing the reactance voltage in series, and the shunt controllers so responsible for inducing the current in series with the lines. So these may be implemented in two different ways: coordinated series shunt controller system and unified series shunt controller system. In case of coordinated series shunt controller, we have two components, the series controller and a shunt controller, which have been coordinated with alpha wave control. So this series controller induce the reactance voltage in series part of the line, whereas shunt controller inject current in the line when the connection is being made. This may be done with a coordinated control system. The other one is actually unified series shunt controller. So here the series controller and the shunt controllers are linked by a DC power link. The series controller inject reactance voltage in series with the line, and the shunt controller inject current at the point of connection. And since these two are interlinked by a DC power link, so there may be exchange of power also. With the help of this compensation, the variable impedance included in the line can compensate for the reactance drop. So as long as this reactance drops are in phase quadrature, the system becomes stable, and so that actually the power flow would be maximum. Now let us revise the entire session with the help of the multiple choice questions. Number one, facts stands for. We have seen the definition, the meaning of the facts, and why we are using all these things. Facts stands for flexible asynchronous current transmission system. The option A is flexible asynchronous current transmission system. B, the factors affecting carrier transmitting service. C, flexible alternating current transmission system. D, the flexible atomic centered transportation system. We have four options here. The most relevant option is C. FACTS stands for Flexible Alternating Current Transmission System. This is a new technology being introduced in alternating current transmission at higher voltages. Let us go to the second question. FACTS is a new transmission technology too. This technology is being used for what? Control load and power factor, limit the power flow, improve voltage and power factor, enhance controllability, and increase power transfer capability. As we have already seen in the performance of the transmission system, the new technology FACTS, which enhances the controllability of the power system and at the same time increases power transfer capability. Therefore, option D may be appropriate. Yes, the answer is D. The FACTS is a new transmission technology to enhance controllability and increase power transfer capability. The objectives of FACTS is to convert AC power into DC, keep power flow in designated routes, reduce line losses, none of the above, which is a relevant answer. The main objective of facts is to keep the power flow in a designated row, not for converting it AC into DC or reduce the line losses. Let us see the answer. Answer B is correct. So the objective of facts is to keep the power flow in a designated routes, that is intended routes. 4. Facts controller is. Then the device facts controller. What is this? We have already seen the definition of the facts controllers and types. Let us see. A power electronic based device system, a static equipment that provides control of one or more AC transmission system parameters, both A and B, and none of the above. Facts controller is a power electronic based system as well as a static equipment that provide control of one or more AC transmission system parameter. Hence, the answer C might be correct. Let us see. Yes, answer C, which is both A and B, a power electronic based system and a static equipment that provide control of one or more AC transmission system parameters. Fifth one, a facts controller controls line parameters by including what? Let us say series and shunt impedance, voltage and current, phase angle, all of the above, which is the correct answer, which is the relevant answer. A facts controller controls line parameters by including series and shunt impedance, voltage and current, phase angle, all of the above. What might be the answer? As I have already seen, the facts controllers are nothing but the variable impedance. A series controller introduces voltage in series with a line, whereas a shunt controller induces or injects the current in the line. It also corrects the phase angle. Hence, the answer would be D, all of the above. Let us see. Yes, it is D. A facts controller controls line parameters by including series and shunt impedance, voltage and current, phase angle. Hence, all of the above is the correct answer. 6. A series facts controller inject dash in series with the line. In the previous question, we have seen, but now it is specific. A series facts controller inject what in series with the line? Let us see. Voltage, current, both A and B, none of the above. A series facts controller inject dash in series with a line. As we already seen, the function of the series controller is to inject the voltage in series with a line. Therefore, answer A be correct. A series facts controller inject voltage in series with a line. Let us see whether it's correct or not. Yes, it is A. A series facts controller inject voltage in series with a line. Next question. A shunt facts controller inject dash into the system at the point of connection. From the question 6, it is contrary. A shunt facts controller inject dash into the system at the point of connection. Let us see the options. Power, current, both A and B, none of the above. A shunt facts controller inject dash into the system. We know that the facts is responsible for increasing the power transfer capability. Is it correct then? As far as shunt facts controllers are concerned, not the power. A shunt facts controller inject current into the system at the point of connection. We have already seen this in the functions of shunt facts controllers. but not both A and B, or none of the above is also a wrong answer. Therefore, let us see whether it is B or A. Yes, it is B. A shunt FACTS controller inject current into the system at the point of connection. Therefore, answer B is correct. Now let us move on to the question number 8. A combined series controllers provide. A combined series controller means we have independent series controllers placed in each line. Then what are they going to provide? Let us see the options. Independent series reactive compensation for each line. Transfer real power among the lines via the power link. Both A and B, or this both A and B statements are true, or none of the above. A combined series controllers provide, as I said earlier, independent series reactive compensation is being done with the help of series controllers in each line. Since they are unified, the real power among the lines may be linked with the power link. Therefore, answer A and B both are correct. Hence, answer C should be correct or appropriate answer. Let us see. Yes, answer C, both A and B. That means a combined series controllers provide independent series reactive compensation for each line. Then, in addition to that, it transfers real power among the lines via the power link. Hence, NC is correct. Question number A. A combined series shunt controllers inject what? Is it only current? Is it only voltage? The power like this? Let us see. Current into the system with the shunt part of the controller. Voltage in series in line with the series part of the controller. Both A and B. None of the above. A combined series shunt controller inject current into the system with the shunt part of the controller. Voltage in series in line with the series part of the controller. Both A and B. And none of the above. As we have already seen, a series controller inject voltage in series with the line, whereas a shunt controller inject current at the point of connection. Therefore, statement A, current into the system with the shunt part of the controller is being done with the help of a shunt controller. It is true. Then the voltage in series in line with the series part of the controller, that is being done with a series controller. It is also true. Hence, the appropriate answer would be both A and B. Let us see the answer. C, correct. Both A and B statements are correct. Because a combined series shunt controller means it has got both series controller as well as shunt controllers. A series controller injects voltage in series in line with the series part of the controller. The main function of the series controller is that. And similarly, a shunt controller inject current into the system with the shunt part of the controller. Therefore, both statements are correct, hence the answer C is correct. Question number 10, the last one. The transmission of electrical power is carried at high voltage AC as it offers the advantage of what? Let us see. Reduce volume of conductor material, making it economical. Reduce line losses and hence increase in efficiency of transmission. Decreased percentage line drop. All of the above. The transmission of electrical power is carried at higher voltage in AC system as it offers the advantage. Reduced volume of conductor material making it economical, reduced line losses and hence increase in efficiency of transmission, decrease percentage line drop. As we have seen in the beginning itself, high voltage AC system has got several advantages in which there will be reduction in the conductor material, there will be reduction in the line losses, and there will be reduced percentage drops. Therefore, statements A, B, C are all correct. Hence, the answer would be D, all of the above. Let us see. Yes, it is D. Hence, the transmission of electrical power is carried at high voltage AC system because it offers these advantages. That is, reduction in the conductor material being used, hence it becomes economical. There will be reduction in the losses, hence the efficiency increases to a maximum value. Then the line drops will be minimum so that the quality of the power can be supplied. Hence the final answer is D. With that, we have completed this session with a new technology of transmission as flexible alternating current transmission system, in which we are going to use the power electronics based systems and other static components in order to increase the power transferable capacity, at the same time the controllable capability, and the power can be routed in designated routes or intended routes so that the transmission line can be effectively utilized. With this, we are going to conclude. Thank you.